Okay guys, I wanted to have a quick look now at this bending moment diagram. So the bending moment diagram, we've got a similar scale on the bottom of distance, and then our y-axis is also in force, but it's the bending moment force. So it's a good idea to be able to use those same distances again. And the table height is a little bit problematic at this stage because we don't know how high we're going, but I can do some quick calculations. Now with the bending moment force, the value that we're going to get is actually, and you would have learnt this from the first video, the YouTube clip that you read, that the relationship to the area of these sections is actually our value of bending moment force. So we've got this little area in here as well, that 2.5 times 6, and then we've got that area there. Now also remember that we always start and finish on that 0 line with our bending moment diagram. So we're going to start there and we're going to finish there. So the first one there, I knew that I went up 32.5 kilonewtons and across to 3 meters. So if I did that there, 30.5 times 3, that area comes out at 97.5. This one here was 2.5 times 6, and that's equal to 15. The last one I don't really have to count because I know that it comes back down to 0. But if I add those two up there, I get 112.5. That is my top value. That is the height that I need to go. So if I was to work up in increments of 30, 60, 90, 120, I'm going to get my table that's going to be fairly good to work with. So there you can see there I've got my distances of 3, 6, 9 from my beam above. So that first point at 3 meters is that value there, 97.5. So if I find 97.5, which is going to be around about there, I can draw a line straight up to there. My next point on the 9 meter line is still an addition. Now the point here is anything that is above the positive force, above the 0 line, moves the bending moment diagram in a upward motion, and then when it falls below the line, that's when we're coming down. So this is still above the line at 2.5, 15, so we have to add 15, that goes to 112, and that 112 is probably around there somewhere. So I can draw a line that goes up to there, nice and straight. And then, like I said, we don't have to do anything else but come back down to the 0. So that's a fairly rough and ready type of explanation, guys, but I hope that explains how we create shear force diagrams and bending moment diagrams.